Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled The Nebulous Realm of WR 134. So what do we see here? Well, here we see an image of the nebula known as WR 134. And WR stands for Wolf-Rayet star, and those are some of the hottest stars and brightest stars that we see. Now, they may not seem the brightest in the sky. That's because a lot of them are far away, which makes them look faint. They're also hidden within the nebula, which dims their light. But they are some of the biggest, hottest stars that exist. Now, they are putting out a lot of energy, but they're also expelling a lot of material. There's so much energy that their outer layers are unstable and expelled out into space. So this is quite different than other types of things like a supernova, although a star like this may eventually become a supernova and explode. Right now, we're just seeing instabilities where those outer layers are being pushed out into space. So this is the region that is now clearing in the center, and we can see kind of how the shock wave goes out from the center there in the various arcs that are present within the nebula here. Now, this type of star is also present in a star-forming region, so there's going to be a lot of excess gas and dust around. Stars are still forming here, so this is very recent formation, and the reason for that is that these Wolf-Rayet stars do not live for a very long time, maybe a million years or so. They're very short by astronomical standards. So the fact that they're still here means that other stars, like our sun-sized stars, are still in the process of formation. And while this star may form, go through its entire life, and die, long before a star like our sun would even form in a region like this. Now, other stars have stellar winds like this, including the solar wind of our own sun, which pushes out material away from the sun. But we're thinking this is a much bigger star, remember. This thing could be 50 to 100 times the mass of our sun. And its amount of energy output is not just proportionally more, but exponentially more, giving out tremendous amounts of energy, and its stellar winds are also then that much stronger than that of our own sun, and can push away all of this material. So our sun, by comparison right now, has a very weak stellar wind that pushes some material away, but nothing like what we see here. Now, these do have a lot more fuel than our sun, but they go through it at a tremendous rate, much faster. That's why they live a lot shorter time. So even though they might have 50 times the mass of our sun, 50 times the fuel, they will go through it so much faster that they may only live a million years, whereas a star like our sun might live for 10 billion years. And that's how fast it goes through its fuel, how much energy it is constantly putting out every single second. So what we're looking at here, again, is that nebula, and we're seeing the glow of ionized hydrogen and oxygen gases that are excited by the hot star that causes them to glow, and that star is what is illuminating this entire region. So that was our picture of the day, titled The Nebulous Realm of WR 134. We'll be back again tomorrow for the next picture, previewed to be second place. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.